Bismillah ar-Rahman ar-Rahim. Welcome, my dear student. This is a new lecture of the course of numerical analysis, and we shall start the first item to review what we study in the previous lectures. We start on chapter 3, solution of nonlinear equations. And discuss the closed domain methods. One of them, the bisection method, and we say that to start bisection method we must have some inputs which is two values a and b that defines an interval containing the root and satisfy the condition f of a times f of b less than 0. We take an example and solve it step by step. This is the previous lecture. Today we shall discuss the second method in this chapter, which belong to the second class of methods, which name is open domain methods. I think that we agree that we must write with the lecture, and you must write now with me the title, open domain method. Here we don't have interval, we don't have 2 points, we just have 1 point called initial guess or initial estimate, okay, which may be any point. And then we have some methods, we shall take from them Newton methods. And next item you must write in your note, Newton methods. Newton method. What is Newton method? The problem is solving the problem f of x equals 0 with an initial estimate x naught. It may be near the root alpha. The law of the law of Newton method is xn plus 1 equal xn minus f of xn over f dash of xn with n equal 0, 1, 2 and so on. Let's write this formula in our class, and then let us write it step by step. In the first we have x naught. In the first we have x naught given, then we evaluate. If we have x naught given, then we have evaluate x1. We put in this formula n equals 0, so we have x1 equal x0 minus this fraction we have up x f of x0 and down the derivative at x0. This is the first value of root. This is the first estimate for the solution. Okay, then we have now x1, so the next step we evaluate x2 equal x1 minus, we have the fraction f of x1 over the derivative at x1, and so on. So the law is, or the formula is, xn plus 1 equal xn minus f of xn over f dash of xn with n equal 0, 1, 2, and so on. At every step we must evaluate the value of the estimated root, and then we check if it is the root or not by satisfying the original problem f of x equals 0. So if the value of f of x1 or f of x2 is near 0, so it is a good estimate for the root. Let's take an example. Use Newton formula to obtain the root alpha of the function f of x equal x square minus 4x plus 4 starting from x naught equal 0. Let's write the problem with me. We have to use Newton formula to obtain the root alpha, and the function is f of x equal x square minus 4x plus 4 starting from x naught equal 0. So what is the inputs? The inputs are first the function. The function is f of x equal x square minus 4x plus 4, and we have to evaluate the derivative. The derivative of x square is 2x and minus 4x is minus 4, so the derivative is f dash of x equal 2x minus 4, and we have also x naught. We have x naught, okay? X naught equals 0. We evaluate the function at it, so f of x naught equal, here is x equals 0, so we have just 4, and we have to evaluate f dash of x naught, we have minus 4, so this is the first generation of that. Okay, now we shall start the first step of using the rule. The formula is, I'm so sorry. The formula is xn plus 1 equal xn minus f of xn over f dash of xn. We put n equal 0, so x1 equal x naught minus f of x naught over f dash of x naught. X naught here we have 0, and the fraction f of x naught we have 4, and f dash of x naught minus 4, so the result is minus on minus, the result is positive. 4 over 4 is 1, so the result is 1, so x1 equal 1. Do you understand this step? Let's see if you are with me or not. Let's see.
Doctor,
Yes.
can you repeat it, please?
Okay.
Can you repeat it, please?
What is your name, please?
Madiha.
Okay. What?
Madiha.
Okay, Madiha. Okay. We have first this is formula. which we use in each iteration. We put n equal 0. So do you understand how we obtain this formula from it?
I had problems with the voice. I couldn't hear you, but I will rewatch it when you upload the video, doctor.
Okay. This is xn plus 1. Do you understand? Do you hear me now? xn
Yeah,
plus
I can hear
1.
you now. Mm.
What is the value of n equals 0?
1.
Yeah,
No,
it's
n
x.
equals 0.
Now we
Yeah,
have
okay.
x1 in the left. Okay, in the right. xn. What is the value of n equals 0?
0.
X naught. Okay. So
So,
in the fraction here we have up f of xn. When n equals 0, it is f of x naught. Okay.
okay.
And down here we have f dash of xn. When n equals 0, f dash of x naught. Now it is clear how we obtain the first.
I have a question.
Yes.
Is f dash an inverse or another function?
No.
Or a
It's the derivative. No. It's the derivative.
Okay.
We have here.
The derivative.
I'm sorry. The internet have some problem. Please wait. This is f of x. Okay. Do you understand me, Madiha? F of x equal x square minus 4x plus 4. F dash of x equal to x plus minus 4. Do you understand
Yes,
this?
okay. Yes.
Okay, it's the first derivative. Okay.
Okay.
Okay. Now let us substitute in this formula we have done here. X naught is 0. Okay. So we write it 0. And f of x naught is 4. Do you understand how we obtain f of x naught, f of x naught, or f of 0 equal 4 or not?
We substitute with 0 in the x.
Yes, in
Of
the
the
function.
equation.
Okay.
Yes.
So we have 4 here up in the fraction, and down we have the derivative. F dash of x naught is minus 4.
Negative 4.
Yes. Then the result is 1. Now you understand this step?
Yes.
Okay, good, Madiha. Good, very good. Next step. What is the next step? We evaluate the function at x1. Let's take another student, Isra. Do you hear me, Isra?
Yes, doctor.
Okay, please evaluate the function f of x equal x squared minus 4x plus 4 at 1. X equal 1. I want every student to work with me, okay?
Equal 0.
Equal 0. Let's
No,
see.
equal 1.
Equal 1.
Yes,
Sorry.
equal 1. F of x1 equal 1. And what is the derivative at 1?
0.
Negative 4.
2. Negative 2.
Negative 2.
Yes, negative 2.
I'm
That's
negative
good. So, is x1 is a root for our function? Yes or no? The answer is no. F of x1 must be 0 or near 0, okay? If it is not so, we didn't reach the solution of the problem. We must continue iteration. The next step, we put n equal 1 in the formula of the rule. And let us see another student. Yasmin Shazli.
Yes, doctor.
Please put n equal 1 in the Newton formula and say me the new iteration formula. What is it? xn plus 1 will be
Okay.
xn plus 1 will be what? x2.
1.
xn plus 1. When n equal 1, the result is 1 plus 1, which is
2.
2. Yes. Equal xn. What is
X1.
x1? Yes, that's good. And up here we have f of
minus
x1
1.
over.
1.
Yes, that's good.
X1.
Now let us substitute. What is x1? Here. x1 equal 1. Right?
Equal 1.
Yes. Minus. We have up and down here, and we must we have a fraction. Please give me an what is a fraction, please? Fraction, please. Yes, fraction. Fraction. What is up here? F of x1, which is
1.
yes, it's 1. And down here we have
Minus 2.
minus 2. Yes, it's good.
Negative
Now, can you evaluate this?
3 over 2.
The result is 1 plus half, which is
1.5.
1.5.
1.5.
Yes, it's good. It's good. You are okay. It's good. Now, is x2 is a root for our function? Let's take it our function down here. Is x2 is a root? We must evaluate f of x at 1.5. Let's take another student to work with me, okay? آية سلمان.
حضرتك كده.
Okay, you must evaluate the value of f of x at x equal 1.5. Please say me what is the result.
Okay.
This is a function here with you.
Minus 1.
So we have f of x
Minus 1.
2 equal minus 1. Let's take it from down. F of x2 equal, are you sure?
Quarter. F of x2 equal quarter. 0.25.
Yes, doctor. 1 over 4.
Which is
I am sorry.
2.5.
1 over 4. 1
Okay,
over,
this
1
is
over
okay.
4. Okay.
Is this means that we reach the solution of the problem? Sure, no, but we are near the solution now. We have 2.5 after the decimal sign. Okay, so we are near, but we have not the solution. So we must repeat more iteration. So we evaluate f dash of x at 1.5. Please evaluate f dash of x at 1.5.
Negative 1. Negative 1.
Negative 1. Okay, let's write it.
At 1.5, does that mean when x equal 1.5?
At 1.5 means we have here 3 minus 4 the result is minus 1.
-1. Negative
Is it
1.
true?
Yes.
Hmm?
It's not here.
2 and 1.5 is 3. Minus 4, the result is minus 1. What is the problem?
-1.
Negative 1, yes.
No problem.
Negative 1. Okay. Now we have to go to the next step. We put here n equal what?
2.
2. Yes, it's good.
2.
N equal 2. Let's do n equal 2. Here we have x what?
3.
3.
X3 equal.
And here
2.
2.
X2
And here
minus X.
2. And here 2. And now
If it is
we
x2.
substitute. What is
Doctor,
x2?
when do we stop substituting?
We substitute here. Okay?
When do we stop and have the correct answer?
When we have another
Please,
missing
please
here.
let us answer this question after we end this step. Okay? What is x2? 1.5
1.5.
minus. We want fraction. We want fraction. Please give me a fraction.
Quarter.
Fraction. What we have up here?
Quarter. 0.25.
Yes, 25. And we have down
Minus 1.
minus 1. So we have 1.5 plus 0.25. The result is 1.75.
0.75.
And now, my dear, obtain the function at the new x3. What is f of x3?
يلا.
0.0625.
0.0
625.
625. And you see here f of x2 equal 0.25. f of x3 equal 0.0625. And I think that f of x4 will be 0 0, and so we here is the table. This is f of x3. Okay, so we are near the root, and I think that we must stop making manually evaluating the root, and we go to obtain the root with a program, so we can do much iterations to obtain a very accurate solution. Okay, so we shall if we do manually, we want just 3 iterations as obtained in this table, just 3 iterations. But if we have a program, so we can we make much more iterations. Okay, if one have
So we always stop at the 3rd iteration.
3 iterations, yes. Manually 3 iterations, and computer program we can make 100 iterations. Okay, anyone have any questions at this example?
No.
Okay, let's go to the next step for this method. We shall say that every method we must discuss the error statement of I'm sorry, error estimated of this method to see an error formula for Newton method. We shall discuss here an error formula for Newton method. please write this title for this item of the lecture: error formula for Newton method. First, I think that it is so difficult to understand the proof of the method of the formula, so I shall just take the last formula and discuss it. Okay, so the proof of the error formula is omitted. We shall just take the result. The result is, if we have alpha is the solution of the problem, then we have alpha minus xn plus 1 equal approximately m times alpha minus xn all square. I repeat, alpha minus xn plus 1 equal m times alpha minus xn square. What is alpha? The root or the solution of the problem. What is xn and xn plus 1? They are two iterations which has number n and n plus 1 for the solution using Newton method. Okay. So what is the result of?
No.
Yes, you can ask. Who ask?
What is m?
M.
What is m?
M. It's a constant containing the following fraction: minus f double dash at alpha over 2 f dash at alpha. F dash is the first derivative, f double dash is the second derivative of the function. Okay.
Okay.
So alpha minus xn means the error at iteration number n. I repeat, alpha minus xn means the error at iteration number n. Alpha the exact solution, xn the approximate. The difference is the error. Now in the left,
The error in the what?
the difference is the error. Okay, let's see it in another slide. Yes, here it is. Alpha minus xn is the error at iteration number n. Okay.
Okay.
Alpha minus xn plus 1. Alpha is the exact solution. Xn plus 1 is the numerical solution or approximate solution at iteration number n plus 1. So here in the left we have error at iteration number n plus 1. You understand me? So we have the error at iteration number n plus 1 in the left equal a constant m multiply on quadratic of the error at iteration number n. Or let's write it in another statement. The error in iteration number n plus 1 is proportional to the square error in iteration number n. Let's see it another time. The error in iteration number n plus 1 is proportional to the square error in iteration number n. So if we start the problem, if we start solution the problem with a point is near the root, then we shall obtain the result in a few number of iterations. Let's see an example of this formula. Okay, So we just must remember this formula: alpha minus xn plus 1 equal m multiply on alpha minus xn all square, and the value of m is minus f double dash of alpha over 2 f dash of alpha. Let's see an example. Example: estimate the error in Newton method for obtaining the root of the function f of x equal x to the power 6 minus x minus 1 equal 0. The answer: this is a formula, okay, and we write m here minus f the double dash over 2 f dash. We just evaluate m minus f double dash over 2 f dash. The function is x to the power 6 minus x minus 1. What is the first derivative? Let's see.
6x power 5. That's it.
Minus
6x power 5.
minus
1.
minus 1. Yes, it's good. So down here we have 2 which is in the formula, and then f dash 6xn to the power 5 minus 1, and we must obtain the next derivative number 2. So we differentiate 6x to the power 5 minus 1. What is the result? 6x to the power 5 minus 1. What is the derivative?
30x power 4.
Yes, just 30x minus 4. So we have f double dash of xn here in the up. We have minus, which is in the formula, 30x n to the power 4. Okay. We can evaluate.
This is the value of the m.
Yes, this is the value of them. And here, so we can evaluate this fraction at a point. Okay, let's write in the question at x equal 1. We must write it xn, not x. Okay. At xn equal 1. Okay. So we must, I think مش موجودة خلاص. So we evaluate this fraction at xn equal 1, which is a chosen point. The result is minus 15 over 6 minus 1, which is minus 15 over 5, which is minus 3. So we can write.
Doctor, is xn equal 1 is a given?
Yes, I write it in the I write it in the question, and
Okay.
if it is not given, it's arbitrary. You can choose it. Okay.
Okay.
So this means that alpha minus xn plus 1, which is the error at step n plus 1, equal the square of the error, which is alpha minus xn all square. The square of the error in step n multiplied on what? On 3.
Not negative 3?
We have the amplitude here, the absolute value. Okay.
Okay.
We take the absolute, we measure the error, so any measure we have the absolute value. Okay, this is the answer. Estimate the error. So the error at step n plus 1 is equal to the square of the error at step n multiplied on 3. I think that it is enough in this part. Okay. I shall stop this video. Okay, and I shall